Today we're going to talk about blood, and later I'm going to show you slides first, but later I'm going to actually prick my fingers, and you see my microscope here, and we're going to be looking at what it looks live from my finger. Before we look under the microscope or on our whole slide images, let's review what are the components of the blood. So blood has cellular components, the cells, and also non-cellular components, which is plasma. It's going to be fluid protein of blood, water proteins, nutrients, and other wastes. So when you centrifuge it, you will have the red blood cells and the cellular components at the bottom and plasma on top. I would say platelets are cell fragments, so they're still cellular components. The majority of the cells in the blood are red blood cells. These cells have the shape, this is referred to as a concave disc. So you can see that in contrast to the white blood cells, they do not have a nucleus. They have this dimple. They look like donuts, but not with a hole. They look like donuts that was flattened because they got rid of the nucleus to be super efficient in oxygen and carbon dioxide transportation. This is their role in the body, and that's why we have so many of them you're going to see on the slides. Whereas white blood cells have a nucleus, also known as leukocytes. They're responsible for immune defense. So they're going to be protecting us from bacteria and other pathogens. It can be parasites, it can be fungi, maybe even foreign bodies. And here you can see two groups of cells. The ones that have this fragmented nucleus, the neutrophil, eosinophil, and basophil, where the nucleus has multiple parts, they have this fragmented nucleus. The nucleus is like in different parts. It can be totally disjoint, or sometimes it's a little bit connected, but they don't have this nucleus together. And we have the lymphocyte and monocyte, where the nucleus is more together. Whereas lymphocyte and monocyte is going to become macrophage. We abbreviate this as like this, macrophage, in the tissue, and then is going to be taking care of engulfing different structures, foreign bodies, maybe fungi, and big pathogens. And they are being referred to, lymphocyte and monocytes, they're being referred to as mononuclear cells. When they come to the tissue, they're referred to as mononuclear infiltrates, whereas these neutrophil, eosinophil, basophil, they're called polymorphonuclear, and their functions are neutrophils are going to be responsible for fighting bacteria. Eosinophils are going to be showing up when we have a parasitic infection. Basophils are going to be telling us, okay, there is an allergic reaction. They have a function in allergic reaction. So now let's have a look at the real version of them. By the way, for those who don't know me, I'm Dr. Alex Żuraw. I'm a veterinary pathologist. I'm the author of Digital Pathology 101, All You Need to Know to Start and Continue Your Digital Pathology Journey. I work as a pathologist, as a veterinary pathologist, on whole slide images. This is how blood looks under the microscope. And this is human blood, at least according to the label of the slide that we have. I did not create the slide, but I see the features of a mammalian blood, because most of the mammal blood is going to look the same, including humans. So let's look at the cells that we just had identified on our infographics. So obviously the red ones. So these are red blood cells. Also in this particular stain, they are red. So it matches, it fits. So all these guys, right? All these friends are our red blood cells. And this is the majority of what's in the blood, because the function of the blood is to carry oxygen. And the function of these cells is to carry oxygen and take the carbon dioxide out. So when we breathe in, they bind oxygen, the hemoglobin, the substance in the red blood cells binds the oxygen, and then when it's being exchanged in the body, then the oxygen stays in the body, the carbon dioxide from the body binds to the cells, to the blood. But there were other cells, right? And I see a few of them. So how sharp these slides are depends, because it is a smear, blood smear, I assume. Yeah, it is a blood smear. And it is a little bit uneven. So it's going to be, some parts are going to be in focus and some parts are going to be not in focus. But even those that are not in focus, we can see that here are some cells that look like these polymorphonuclear cells. Most of them are going to be neutrophils. Like here, we can see that it has this nucleus that has several parts. Here in this case, it has 3 parts, but it's not one nice circle, right? These are 3 different parts. The cell is a little bit bigger, so I drew around it, but it's a little bit bigger than the red blood cells. So this yellow boundary is around this cell, and it's like, what, 3 red blood cells, right? And this is a neutrophil. The eosinophils and basophils have specific functions. Eosinophils are responsible for fighting parasites, and in allergic reactions, whereas basophils are also involved in fighting different things. Specifically, so eosinophils are parasites, and basophils are going to be allergies, anything that has to do with histamine release. So whenever there's an allergic response. And let us look for some more other cells than just the red blood cells. And this one, neutrophil, that we have. Okay, here is going to be another one. This one, neutrophil. And neutrophils, they fight bacteria, are mostly bacteria. And then we're going to, the lymphocytes, let's see if we can, okay, this is another neutrophil. I want a lymphocyte. The lymphocyte was the one with round nucleus. And then I'm going to prick my finger and see what we can see. And it's not, oh yes, this one looks like a lymphocyte. Trailblazers, look at this guy. Slightly bigger than a red blood cells, but not as big as 2. And it has this nucleus inside that is like very round and is not in parts at all. These are lymphocytes. Lymphocytes include B cells, T cells, natural killer cells. They take part in immune response as well. I don't know if we're going to see any basophils or eosinophils, because we would need to have like some specific reaction, allergic reaction or histamine release or something like that. So we would have to have a blood. This one looks like a neutrophil, like a lymphocyte as well. I would like to find a monocyte, which is going to be a macrophage in the tissue. But there are not so many of these. But so mostly, as you can see, mostly red blood cells, and then we have some white blood cells. Most of them are going to be neutrophils. If there is an infection, if there is anything bacterial happening, we're going to have more of them. So if we have a cold and would like to make a smear out of what's coming out of our nose, often we would have a lot of neutrophils. Okay, are we ready for me doing the real life demo? The microscope has a camera on top of it. I have a different slide. I have a slide of intestine. Here, let me share. Whoever is his life is gonna witness me pricking my finger for the histology education for the okay. I don't want to hurt myself very much, just a little bit. Hey. Okay, I have something. I'm gonna do a few dots. Let me take a different one to make kind of a smear. And let's see how it looks under the microscope. I'm taking out the other slide. Oh, I see. They're not stains, my friends. This is my blood. Not too bad. We're gonna go higher magnification. Ooh, nice. Mostly red blood cells, right? And if you smear them thin, then you can see them separately. Okay, not too bad. Let's see if we can see any white blood cells. So this is without any staining. It's just straight from my finger. Dramatic demonstration for what's in the blood. I want to find a neutrophil. I saw quite a few there, but I'm not seeing anything here. Let me go. Lower magnification. Oh my goodness, they're so beautiful. Let me know what you think. I want to find a white blood cell. If you see anything, let me know that I'm supposed to stop. So one of the reasons can be that we didn't stain it, so that there is no stain in them. They are white and not red, like they're. Wait. No, I don't think so. This looks like just some kind of bubble. I'm determined to finding it. Maybe it is one. Let me go through the microscope. Maybe it can be one, but I don't see its nucleus, so I don't know why. I want to see something with a nucleus. But if we see more of them, then maybe that's an indicator that that's them. And you can see when you like play with the micrometer screw on the microscope, you can see that they will have this like thinning. The red blood cells are going to have this thinning in the middle, so they are actually these concave discs. And here are some round cells where we don't see the nucleus very well, but they might as well be lymphocytes. Ooh, several of them. Okay, here's something. Here's another one. Here is a bunch. Let us go and check them out. Oh, well, we cannot check them out more than that because I don't have another objective. I'm an anatomic pathologist, so I work with a 40x objective, and to see them better, we would need 60x, 100x. But yeah, this is our blood, or my blood, that I obtained by pricking my finger with a needle. But a couple of more slides that I would like to show you. Maybe let's have a look at whole slides. That's going to be easier. I have a box of slides, so we could, in theory, do the microscope as well. But I have a bunch of whole slide images, and I want to show you like blood in other organs, right? Can we find blood in other organs? This is a section of heart muscle that you can appreciate. There is a video. I have a video on the channel about how to distinguish heart muscle, but what we're looking for are red blood cells and vessels. So this is a vessel, and this should be red blood cells. Not in focus. I want to see something nice where I can show you the cells. This is blood, but it's kind of like not really. Oh, here you can appreciate that these are cells that are packed together. Oh, here, even better. The black stuff is probably some artifact when this was being stained, but the red are red blood cells. Any neutrophils or anything? The black stuff is artifact. Here would be something that would be a white blood cell. Oh, this is liver in a different stain, in a silver stain. So here we're not going to have the red. And where will we see red blood cells in the liver? In these vessels, central veins. But we need to find a good one that has something in them. A vessel that has blood that is stained nicely. If not, we're going to find a section of liver. I'm not very happy with the blood cells here. No, just FYI, there is a video on liver as well. These are hepatic lobules. They have a central vein in the center, and a couple of other different features, including connective tissue between the lobules. This black thing is the connective tissue. Very nicely seen in the silver stain because it stains the reticulin fibers and collagen. But we are looking for blood, right? Can we find blood here? This is epithelium. Here are vessels. Let's find, this looks like an artery. We want something with blood. This is just proteinaceous fluid. Nothing, just the fluid. Fluid, nope. Here. Woo! Look at this. I mean, the red blood cells are kind of like merged and it looks like fluid, but here we can see the white blood cells. These look like neutrophils to me. Here are a couple of lymphocytes. These could be monocytes. Not too bad. Let's look in the kidney. This is kidney. How do I know that it's kidney? Because when I look at it, I see glomeruli. This round clover-like or flower-like structures are glomeruli. If you see this, you know that you're in the kidney, and the other structures are tubules, but we are interested in blood today. So let me find blood, red blood cells. Here. Look at this. Here, there. Red blood cells. This is a vessel with red blood cells. Another vessel with red blood cells. Here. Here as well. So here, all these. So also when you look at structures in tissue and you are asking yourself, okay, which one is a tubule, which one is a vessel? If you have something that has blood in it, then you're going to know that this is a vessel. Whereas where there's no blood, and also vessels have very thin wall. The nuclei are also like flattened or elongated, not much thicker than the rest of the cell, whereas tubules have more plump cells, round nuclei. This is thicker, and obviously they don't have blood inside. If you're interested in the technology that lets us look at slides like this, called Digital Pathology, there is a book. You can download the PDF for free. This book, you will learn what makes it possible, what is digital pathology for, in addition to education, and how it can help deliver faster diagnosis for patients and better education for students. Let me know in the comments where you are tuning in from, and if it was useful. Thank you so much, and I talk to you in the next episode.